Hello friends, in this video we have come up with the latest question which has appeared in the GATE examination of Electrical and Electronics Engineering in this year 2023. So we are given this circuit here and we are asked to calculate the value for the current I which is flowing through this 200 ohm resistor. So what do you observe here? First of all, we need to simplify the circuit, and the only thing which quickly comes to our eyes is this current source with the parallel resistor. So simply used V is equal to IR for the source conversion and convert this current source to a voltage source like this. So when you're going to convert this, you will be getting the value for the voltage source as 1 ampere, and this parallel resistor will come in series to the voltage source. Please make a note of one important point here. The direction of current source is from left to right. So wherever this arrowhead is, you are going to place the plus sign, the higher potential sign of the voltage source in that direction only. So you should be very focused on this, that whatever is the direction for arrowhead, there should be the this sign of the higher potential. Now this circuit, just adjust the parameters, adjust the components and redraw the circuit here. You will see that this resistor and this resistor, they both are in series to each other. So we have just simply placed them close by, and this 1 volt voltage source is appearing like this. So we have just redrawn the circuit here. Now we can assume a common node here, and let's say the voltage at this node is VA. Now if you are able to calculate the value for VA and then using Ohm's law as V divided by R to calculate this value for current through this branch, that means we will be able to calculate the value for the current through 200 ohm resistor, because this 1 kilo ohm, 200 ohms and this 1 volt voltage source, they all are in series. So that means the same current would be flowing through this branch. So let's calculate VA by applying Kirchhoff's current law here. If we assume the outgoing current to be positive and incoming current to be negative, so let's make up our equation now. Let's take this first branch here, which consists of 2 kilo ohm resistor and a 2 volt resistor. So just see the polarity of this voltage source here. The plus sign is appearing upwards and the minus is downwards. So the potential, in place of potential difference, we can write VA minus 2 divided by 2000. This is 2K. K means 2000. So simply write like this: VA plus 2 divided by 2000. Let's take the second branch in which there is only a 2 kilo ohm resistor. Now because there is no other voltage source present here, so that means the terminal is simply connected to the ground. So VA divided by 2000. Okay. Then this 1 milliampere current source is given here in the third branch. The direction of this current source is fixed. It is incoming. So we have taken as minus 1. And here in this branch, just observe the potential of this voltage source here. Now the plus sign is appearing downwards. So how we are going to write the potential of this particular branch here? So it is written as VA minus of minus 1, which is equal to VA plus 1, and that is what is written here, divided by the series or the addition of these two resistors, which is 1000 plus 200, and this is equal to 0. Now one important point is there. This is a single equation and we are having only one variable, which is VA. So just readjust this equation, manipulate it, and you will be able to get the value for VA as 0.636 volts. Now because we have got the value for VA, can we now calculate the current value through 200 ohm resistor? Of course we can. And this is how you should be able to get the value for I, which is flowing through 200 ohm resistor. So simply substitute the value for VA here and you will be able to get the answer as 1.36 milliamperes. So I hope that you have got the concept of this particular question here. You have to perform the source transformation and just quietly observe the circuit, because this circuit could also have been solved using Kirchhoff's voltage law. But always remember that number of loops means the number of equations and the number of variables. So more the number of equations, more the number of variables, and your calculations will be much lengthier. So this Kirchhoff's current law has given us some parallel branches here, a single node, that means a single variable to be calculated, and that is why our calculations were simpler and faster. So you have to make a good choice by closely observing the circuit whether you should go for Kirchhoff's voltage law or you are going for Kirchhoff's current law. So this question, I hope it is clear and the concepts are done. So thank you and happy learning.